Okay, this is about radians and the unit circle and positive and negative coterminal angles. So the unit circle has some rules applied to it. We're going to talk about it as if it's a roller coaster. The roller coaster car always starts here on your XY axis. So notice the XY axis. So this is where we always start. And also notice the direction that the roller coaster is facing. It's about to go counterclockwise. Just like the quadrants along a plane go counterclockwise, your roller coaster is always supposed to go counterclockwise. The unit circle has a center at 0, 0 and a radius of 1. That's why it's called the unit circle. So it's 1 up, 1 down, 1 left, 1 right, etc. So when we discuss radians, we're referring to the distance traveled along the track of the roller coaster. So if your roller coaster goes all the way around a unit circle, how far has it traveled? If I stretch this out, how far along the track has it traveled? Well, what's another word for distance along the edge of a circle? It's the circumference, right? So the circumference of the unit circle, so circumference is 2 pi r. Well, since r is just 1, if he went one full lap like he did, he traveled 2 pi radians is how we talk about it. What if he goes backwards? So I talked about how the roller coaster always goes counterclockwise. Well, if he goes backwards, we say he went negative 2 pi radians. So the positive and negative tells you the direction he's going. Positive is the correct normal direction, counterclockwise, and negative is going backwards, clockwise. 1 radian is officially defined as when the distance traveled along the track is the same length as the radius. So if I could take this orange line, which we know is 1 unit, and I could curve it around the circle, and we would assume it's the same length, that's officially 1 radian when it matches the length of the radius. Okay, the stuff is in red is definitely stuff you're going to want to jot down in your notes. I can't stop, so you need to pause the video whenever necessary to make sure you copy that stuff down. One thing we didn't necessarily mention in the slideshow together is that half a circle would be just 1 pi, right? I talked about how a full circle is 2 pi. So then just half a circle would be 1 pi. Okay, let's say you're at the fair or whatever and your friend gets on the roller coaster and it started where it was supposed to. And then you go off and you get some cotton candy and all of a sudden the roller coaster is stuck up here. What might have happened while you were gone? We all know the roller coaster started here. What might have happened? Well, let's see. Hopefully you came up with some ideas of what might have happened. One thing that might have happened is it just went that far and got stuck. If that's the case, how many radians did it travel? What is this spot in radians? So you know a whole circle is 2 pi. Logically, half a circle is pi. So what would that leave up here? Half of that, pi over 2. That's one thing that might have happened. But you weren't there. Maybe this happened instead. Let me see if I can go back. If this happened instead, how many radians is that? One more time. He's going to start at the beginning, a whole circle, and then that much more. One thing to be aware of when we talk about radians, we always use improper fractions. Pause the video and see if you can name what he just did. I'll show it one more time. All the way around and that much more. What would that spot be as an improper fraction in radians? Hopefully you got 5 pi over 2, right? 2 pi, which is really 4 pi over 2, plus pi over 2. That same spot could be named 5 pi over 2 if he went an extra lap around. So this is bringing me into coterminal angles. The spot can have multiple names because it depends on how many trips around he did. Could anything else have happened while you were gone? What if this happened? The roller coaster completely malfunctions and goes backwards and then gets stuck. Pause your video and see if you can come up with the name for that spot for what just happened in radians. So it went, I'll show it one more time. Backwards, that far, how many radians is that? Well, from here to here is negative pi, and then another pi over 2 would be negative 3 pi over 2. So that exact same spot has all those different radian titles. Let's see if you can do it on your own. Watch the roller coaster and see how many radians he traveled. Here we go. That's where he stopped. What is the name for that spot in radians? I'll show it one more time. 1 trip, 2 trips, and that much more. How many radians did he travel? So 2 trips is 2 pies plus another pi. That would be 5 pi. Okay, so we need to know how to convert from radians to degrees. So I just talked about, or before you came to this, you know a whole circle is 360 degrees. They teach you that when you're really young. I just taught you a whole circle is also 2 pi radians, so we can set these equal. If I divide both sides by 360, divide by 360 and you get 1, divide by 360 and reduce it, you get pi over 180. Or if I divide both sides by 2 pi, so back at the top, divide by 2 pi, I get 180 over pi. Since they both equal 1, I can multiply anything by 1 and get an equivalent expression. So these are your conversion ratios. I know you guys use these in chemistry and other classes. Since they're equal to 1, I can multiply anything by pi over 180, any degree by pi over 180, and I can multiply any radian by 180 over pi. So jot it down in red, pause the video if you need to. If you're converting 2 radians, you want to use pi over 180. If you're converting 2 degrees, you want to use 180 over pi. And it'll be pretty obvious as we go. When you're talking about something in radians, it should have a pi and it should be on top. When you're talking about something in degrees, it should not have a pi. So if I need the pi to cross out, I need it to be on the bottom. And I'll show you what I mean in the next slide. Okay, convert to radians, 210 degrees. So this is degrees and I want to go 2 radians. So I need to use the pi over 180 because I need my radian answer to have a pi on top of the fraction. Then I can just kind of merge those together, 210 pi over 180, and then I start reducing it. First I see the zeros, so I know they're both divisible by 10, so I can divide both by 10 real quick. Then 21 and 18, those reduce. I know 3 goes into both of those. Divide them both by 3, and I get 7 pi over 6 radians. That is the answer. Improper reduced to get full credit for your radians. Why don't you pause the video and try negative 145 on your own? The negative doesn't do anything. I'm still converting to radians. Just FYI, the negative will still be there in your final answer, but it doesn't change anything I'm doing. I'm converting to radians, so I multiply by pi over 180, merge them together and reduce them. Maybe it takes you a little math on the side to do the reducing, but you should have gotten negative 29 pi over 36. Okay, converting to degrees. So now I'm trying to convert to degrees. I need that pi symbol on top to go away. The only way I can cross out a pi on top is if I multiply by the fraction that has a pi on the bottom, because then a pi on top and a pi on the bottom cancel out. Now, you could multiply 5 times 180 if you feel the need, but this is all multiplication or division, and I can do any order I want. So why don't I instead, 3 goes into 180, 180 divided by 3 leaves me with 60. Now there's nothing left on the bottom, and now I just have to do 5 times 60, which is a lot easier math. So work on practicing your reducing fractions. So 5 pi over 3 is the same thing as 300 degrees. Pause your video and try 7 pi over 12. I'm going to pop up the whole answer with all my work in a minute. See if you can pause it and do 7 pi over 12. So you needed the pi's to cross out, so you needed to multiply by 180 over pi. The pi's cross out. I guess I didn't pop up the whole answer. Sorry, I'll walk you through this one. Now I've got 7, 180, and 12. I do not want to multiply 7 times 180. Instead, I'm just going to start reducing this. Maybe you see a really big number that goes into both of those, or maybe you see a smaller number. I see that they're both divisible by 3. So I divide 12 by 3 and I get 4. I divide by 180 by 3 and I get 60. Now I've got some smaller numbers, but they are still reducible. 2 goes into both of those. Actually, 4 goes into both of those as well. So divide 4 by 4, divide 60 by 4. Now I'm left with 7 times 15, which is a little easier, 105. That should have a degree symbol. Okay, positive and negative coterminal angles. So remember when you got the cotton candy and it could have gone around once or twice or even backwards? Those were all called coterminal angles. A positive coterminal angle is when you go counterclockwise, the correct direction, and the answer is positive. To get a positive coterminal angle in degrees, you just add another full circle. You add 360 degrees. Maybe it went around one extra time that I didn't see, so you add 360. To get, oh, and then your answer needs to be positive, and we'll talk about that. To get the positive coterminal in radians, you still add a full circle, but a full circle in radians is really 2 pi. So you add 2 pi until you get a positive answer. This is really important. If the answer blank says positive coterminal angle and you write a negative number down, you already got it wrong. So make sure you keep adding a full circle until you get a positive answer. Negative coterminal answer, it means it went clockwise and the answer should be negative. You do the same thing, but subtract. Subtract a full circle until you get a negative answer. Subtract a full circle until you get a negative answer. Okay, let's do it in degrees. 210 degrees. There are an infinite number of positive coterminal angles that would put you on the same spot, that would stop the roller coaster at the same spot. We just need one. And it's common practice, but you could try subtracting 360, but that's a little too big this time, right? That would give me a negative answer. So I'm going to add 360, and 570 degrees is a positive coterminal answer. It's positive, and it would land me in the same spot, so that's my answer. Negative coterminal, subtract 360, negative 150 degrees, it's a negative answer. That is my negative coterminal. Why don't you pause the video and try 410 degrees? So positive coterminal, add 360, 770 degrees is a positive coterminal angle. Negative, subtract 360, and I get 50 degrees. Is that a negative coterminal answer? No, 50 degrees is still positive. So technically, if you realize this was bigger than 360, you could have subtracted, and that could have been your answer for positive coterminal. So there are an infinite number of positive coterminal angles and negative, but we try to stick with one of the two that are closest, right? Don't add 360 10 times just to make me have to check and see if you got it right or not. So this is not a negative coterminal. This is an alternate answer to positive coterminal if I need it. I do it again to get my negative answer. Negative 310 is my negative coterminal angle in degrees. Finally, radians. Add a whole circle, but what's a whole circle? A whole circle in radians is 2 pi. So now I need a common denominator. So this is over 1, so times 2 on top and bottom. Sorry, times 3 on top and bottom. So common denominator. Add the tops. 11 pi over 3 is a positive coterminal angle in radians. Negative, subtract the whole circle. I already did the common denominator work, so really I could have jumped right here with a negative sign in the middle. Subtract the tops. I got a negative answer. Negative pi over 3 is a negative coterminal answer in radians for that same spot on the unit circle. Okay, you try these. I am going to, on my next slide, just have the answers. So you need to pause the video and try these on your own. Notice the directions. Every answer for number 1 should be in radians. So first you're going to convert and then keep it in radians. And number 2, you're going to convert it to degrees, and then your other answers should be in degrees. Pause your video so you don't see the answers. Try these on your own. Okay, these are the answers you should get. Notice I put 2 for B because, yes, adding 360 worked, but also subtracting 360 worked. So these are 2 of an infinite number of possible answers, but hopefully you got these ones instead of adding and subtracting more times than necessary. I hope this helps.